Hi, welcome to lesson 20D, Boxplots. We're going to be looking at what boxplots are and how to use them to view some information. Generally, boxplots are another good representation or another visual to represent data. They're sometimes called box and whisker plots, which you'll see in a second why that could be. And the information that's provided is from the 5-number summary. So we got the minimum value, the lower quartile, the median, which is the second quartile, I guess, or the middle quartile, the upper quartile, and the maximum value. So in a box and whisker plot, the ends of the box are the upper and lower quartiles. So Q1 is right here. That's the bottom of the box, or the left end of the box. Q3, the upper quartile, is the top or the right end of the box. And so this whole span here, whoops, is the interquartile range. The median is marked with a vertical line inside the box. So here's the median right in here, or Q2. And then we've got the two whiskers, and the lower whisker goes to the minimum value, and the upper whisker goes to the maximum value. Or sometimes it'll go to the last value that's not an outlier, and sometimes outliers will be marked with an asterisk if it's above the certain upper boundary, as you'll see in a few minutes. Here we see that in this particular example, the minimum value is 3, so we see that 3 is right here. Q1, the lower quartile, is at 13. The median is at 20. The upper quartile, Q3, is at 29, and the maximum value is 42. Okay, so that just kind of shows basically when you look at this, you look at, you'll be seeing, okay, with the majority of the data, the 50% of the data in the middle of all the data is going to be in this box. So it kind of shows you a good sense of where the data is, from 13 up to 29. We see that the maximum goes all the way up to 20, or is up to 42, and the minimum values go all the way down to 3. Okay, so we kind of see the range of the data, and the range is determined by looking at the difference between the maximum and the minimum values. So the range is all of that. And so that kind of, you get a kind of an overview of what all the data looks like from there. If we compare box plots with diagrams or histograms and bar charts, we can take a look at how they compare here. So a symmetrical distribution, the box would be right sort of pretty much in the center between the two whiskers, and the median would be right in the middle of the box. If it's positively skewed, the right whisker is longer than the left, and the median is more to the left of the box, because the median indicates where the halfway point of all the data is. And if it's positively skewed data, the majority of the data is to the left, and there's just a few data points up, that are up higher that kind of stretch out the average, or the mean is stretched out to the right. And then if it's negatively skewed or left skewed, we see that the left-hand whisker is longer. The median, the line in the middle, is more to the right in the box, indicating that the majority of the data is over to the right of the distribution. All right, so we'll take a look at this data here. And quite coincidentally, there's everything that you can ever imagine on the internet in terms of tools and calculators and that kind of thing that we could use to help ourselves. So first of all, notice that the values are not listed in order. So in order to sorry, pardon the pun, to find the median by examining the values, we'd have to put them in numerical order, starting with the lowest on the left and the highest on the right. But if they're out of order, you could probably just put them into an online calculator. And there's a link to that on D2L on the website. And so I'm going to share this website with you. And here we go. So what we're going to do is we're going to substitute put all the data into this box here, separated by commas. So we're going to have 8, 2, 3, 9. Then we've got 6532. And then 2625. Followed by 4556. Okay, so we put all the data in. You probably want to check just to make sure you have all the data accordingly. And so we got 2, 4, 6, 8, 10, 12, 14, 16 pieces of data. 2, 4, 6, 8, 10, 12, 14, 16. Okay, sounds great. So once you put the data in, we're just going to choose a sample, and you just have to calculate. And so it's going to tell you the minimum value, the maximum value, the range, so the difference between the max and the min. It's going to tell you the size, the number of data values that we have in there. We get the sum, the mean, the median, the mode, standard deviation variance, mid-range. We get all the quartiles, the interquartile range, and any outliers. Okay, so all of that stuff is going to be calculated here with the click of a button like that. So we now know, and it puts all the numbers in order for us too, which is very handy. So the minimum value is 2, the maximum is 9, the range is 7, because 9 minus 2 is 7. There's 16 pieces of information there. The sum is 7.3. The mean is 4.5625. The median is 5. So if we look up here, we got 1, 2, 3, 4, 5, 6, 7, 8. So 8 and 9 are the two middle numbers, and we average those, and we get 5 anyways, because they're both 5s, so that we can verify that the median is 5. The mode is 2 and 5, so there's 2 modes. So there are 4 values of 2, and there are 4 values of 5. So there's 2 modes there. Standard deviation and variance are given. Mid-range of 5.5. I guess that's exactly halfway through the data. And then the quartiles, the lower quartile is 2.5, and the upper quartile is 6. Okay, so that's how, and the interquartile range is 3.5, because we just subtract 2.5 from 6 from the quartiles. Okay, so once we have all that information, then we can go back and we can create, put in all the values here and draw the box plot. So the minimum value is 2, and then we've got Q1, which is, what did I say Q1 was? Q1 is 2.5, so it's halfway between 2 and 3. So yeah, so it is 2.5. The median is 5. The upper quartile is 6, and the max is 9. Okay, so there's our 5-number summary. We want to draw the box plot. So we want to have the minimum at 2, the maximum at 9, and we want to draw a box here. So let's see if I can draw this. And Q1 is at 2.5, and Q3 is going to be at 6. So draw the box there. We'll draw our line. Leave it that width at 5. So there's the median. And then we'll draw the 2 whiskers that go out to the max and the min respectively. And so that is our box plot there. We want to find the range. Well, the calculator already gave us the range, but the range is the max minus the min. And so that's 9 minus 2, which gives us 7. The interquartile range, again, we were given that already, but that's fine. We can do the calculation here. So Q3 minus Q1. So we got 6 minus 2.5. And so the interquartile range is 3.5. So 50% of the data is in that between 6 and 2.5. And the percentage of the data values that are less than 3. So if you recall, we saw that there were 4 2s. Okay, so there were 4 2s. And so there were, and those are all, of course, less than 3. And there was a total of 16 data values. So, of course, that is 25%. Well, that's not drawing very well today. Okay, so 25% of the data is less than 3. We can do parallel box plots as well, and that gives us a visual comparison of the distribution of the 2 data sets. So we can compare them in terms of median range, interquartile range, etc. So what we want to do then is we want to find the 5-number summary for both of these, the old drug times and the new drug times, and then set up a parallel box plot for the data sets to compare the 2 drugs for speed and reliability. So there's the scale or the number line down below. What I'd like you to do is take a bit of time right now and use that calculator that is from the from our class website, and draw your parallel box plot there, and then come back in a second or a few minutes and compare with what I have. Okay, so please pause the video now, and we'll check back in a couple seconds. Okay, so here is the 5-number summaries for both of these. The old drugs, the old anesthetic drug on the left, and then the new one on the right. So, once we get all the values, then we draw the box plot. The box plot's sort of what's most interesting about this and gives a nice visual. We see that the old drugs, the ones at the top here, they've got, a larger range. They go from 5 up to 21, so the range of 16. In terms of time, this is probably in terms of times for being effectiveness, or as fast as they would be acting. So there's a lot less consistency there. It's, there's a wider range of values. The new drug acts between 7 and 12 minutes, so that's only a 5-minute window. And then 50% of the data for the new is between 8 and 10 minutes. So the IQR is much smaller here. And then for the old drug is going from 8 up to 12 minutes. So that's 4 minutes. So the new drug is more consistent and more reliable in this case. Okay, so because the values are not spread out as much for the new drug, that means there's more consistency, and 50% of the data is in a tighter range, in the 2-minute range, between 8 and 10 for the IQR, therefore it's more reliable. Okay, and then we'll move to outliers. So they're extraordinary data separated from the main body of the data. They can be either much larger or much smaller than most of the other data. And when we use Boxplots, we can have a check here. There's a calculation to see if there are any outliers. So we look for the upper boundary, and in order to calculate the upper boundary, we take the upper quartile, and then we add 1.5 multiplied by the inner quartile range. So remember, the inner quartile range is 50% of the data in the middle. Okay, so it's the big cluster of data that's right in the middle. And so what we're doing is we're taking 1.5 of that. So we're taking the whole 50%, the number of values. We're taking the number of those values and 50% of the middle 50%. Then we're adding another half of that on top of that. So it's basically 75% of the middle of the all the data from the middle. So we're taking 50 or all of that 50% plus half of that again, and we're adding that to the upper quartile. So the upper quartile is already 3/4 of the data, and then we're taking 3/4 of, or 1.5 of the middle data. So 150% of the middle data, and we're adding it on top of that 75% that is the upper quartile. So if there's any values that are larger than that, then we call that an outlier. Okay, so we're really seeing how far away a value has to be an outlier. For the lower boundary, same kind of idea. We take the inner quartile range again, and we we'll take 1.5 of that. So we're going to take the middle 50%, and we're going to take half of it again. So it's all of the 50% plus half of it one more time, and we're subtracting that big clump of data from the lower quartile. So it's again going from the lower quartile, which is the lower 25%, and we're going so far below that if there's any values that are beyond that, then that indeed would be an outlier. So it's so far lower than the lower quartile, then it's got to be separated by a large interval in order for it to be an actual an outlier. Okay, so we'll go back to the calculator that we have online, and we're going to follow Chris fishing for rock bass for 25 days. We'll put in all these values here. Now the inner quartile range of the data, of course, we're going to have to find the median, the lower quartile, upper quartile, etc. Now all this information is going to be given to us from the website, and it'll also tell us any upper or lower boundaries. Okay, generally we will take the IQR. So if we're looking for the upper boundary, or sorry, the upper boundary, we're going to take Q3 and add 1.5 multiplied by the inner quartile range. And then if we want the lower boundary, we'll do the same thing. We'll take Q1 and we'll subtract 1.5 multiplied by the IQR, and that will give us the lower boundary. And then we'll check the values that we have listed up here to see if there are any values that are above the upper boundary or below the lower boundary, and then those would be our outliers if there are any. Okay, so I'd like you to pause the video again, please, and we'll go through and put all these values into the calculator and come back and check your results in a second. Okay, so as you would have seen, whether you do it by hand or do it with the calculator online, you'll end up getting the lower quartile being 8, the median is 10, and the upper quartile is 13. Interquartile range, of course, 13 minus 8 gives us 5. And then when we calculate the upper boundary, we see the upper boundary is 20.5. The lower boundary is 0.5. And then we check back up here to see, are there any values that are lower than 0.5? And we check along, we don't see any. Are there any values that are greater than 20.5? And yes, we do see one, which is 22. And so that's going to be our outlier. So now when you draw the box plot, of course, we're going to do the same thing as we've done in the past. We've got our Q1 or Q3, or median is 10. And then what we do is, so the minimum value is at the end of the lower whisker, which is 3. We just kind of double check to make sure that 3 is the lowest value here. And just scan across here, we see that 3 is the minimum value. And then, so the maximum value is actually the outlier of 22. So we put a little star there, a little asterisk. And then the end of the whisker is not the upper boundary, but the end of the whisker then is the next largest value that's smaller than the outlier. And we see as we go across here, we see that that would be, looks like it's going to be 18. Okay, and then so 18 is the value that we have here at the end of this right whisker. Okay, so that is how we do box plots. So thanks for watching, and we'll see you in class.